want to talk a bit about overtraining and gauging recovery.
Yep.
So there are a couple methods that I've heard about and that I use based on some data that I've seen, but mainly discussions with really informed people like yourself, Brian McKenzie, Kelly Starrett, and others. The two that I'm aware of for gauging recovery of the nervous system and kind of systemic recovery are grip strength, especially grip strength on waking in the morning, and the so-called carbon dioxide tolerance test, the ability to do a long controlled exhale after a few rhythmic deep breaths, which I'm assuming taps into both one's ability to mechanically control the diaphragm, but also how well one is regulating carbon dioxide. First question is this stuff fiction, fact, or a combination of kind of anecdata, as I call it? Are there any peer-reviewed published data? Is your lab working on these things? And am I deluding myself using these tools, or are they useful?
It's not fiction at all. There are, with like CO2 tolerance, there's less published data. We've run a study in our lab looking at the associations between the CO2 tolerance and what we call trait and state anxiety. And those are in the publication process, is what I'll say.
Great.
So you can't really talk about that stuff, as you know, until it's out. But in general, I'd say like there's a reason I'm still doing it. Mm-hmm. I'll just leave it at that.
Yeah, well, assuming it's not a clinical trial, I mean, I think sharing preliminary findings is fine as long as we highlight them as preliminary.
Yeah.
I'm not a reviewer, but I look forward to reading the paper.
Yeah, but as you know, scientific, ethically, like you need to be careful about telling people results before you've gone through that process.
Right, which is why I'm flagging this as these results are not yet passed through the peer review process. So you're hearing about it prior to peer review.
Yep. Having said that, there's enough in that field. I'm not the first one into that field. And so I'm very confident that that's a real thing. In terms of actual tracking recovery, the big picture is this. When we run through a full analysis, when we have an athlete go through our biomolecular athlete program, we're going to run and we're going to look at three major categories. Okay, category one are what we call visible stressors. And then we have hidden stressors. And then we have recovery capacity. Anytime the total stress load outpaces recovery capacity, you're either going backwards in your physical ability or you're reducing adaptability. Now you have levers to pull here. You can reduce stress intake or you can increase recovery capacity, right? What we want in an ideal situation is to be able to implement the most stress possible, because that's the driver of adaptation, recover from that. Now we get the most adaptation. And adaptation being simply a change, whatever change you want it to be. That's our gold standard, right? It's pie in the eye. Some people have endogenous differences. They just recover better. They don't. There are genetic factors. But let's talk about the ones that are manipulatable. If we go to the stress side of it, you want the throttle to be pushed as far down on the ones you want stress from and as far off of the ones you don't want stress, so that the adaptation comes in the exact area you want, and you're not burning gas in something you don't care about, because you're taking that total stress bucket too high. Recovery capacity over there. So here's how you can do that. You can run some analytics and measure what we do with everyone through these very comprehensive breakdowns to figure out what's that physiology look like, hidden and visible, and then what's the recovery capacity. Once we have that blueprint, we can now figure out what are the 2 or 3 things we need to track that are these indicators of what we call performance anchors. So an anchor is something that kind of drags behind you or below you that slows you down. The analogy being, let's say we're going down one of these amazing canyon roads, and I won't say which canyon we're in, so you can stay hidden here. And your car is going down at a certain velocity, and you want to go faster. Most people's first impulse is to hit the gas, the accelerator. We want to push. Well, that's fine, but if your foot is on the brake and you push the accelerator, you might go a little bit faster, but number one, you're wasting a lot of literal gas to go a little bit faster, and 2, you're burning your engine. You're going to blow. The easier solution is just take your foot off the brake. You're going to go faster by just stopping yourself. Then if that's not fast enough, we can hit the accelerator. Everyone wants to just push down, right? More stimulus, more optimization, bing, 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 bing here. Our first analytics are, where are these performance anchors? What's dragging you back? What's putting down the brake? I want to move those 2 or 3 things out of the way, and now let's see how far you get. Oh, look at that. Your recovery capacity has gone way up. Your adaptations are happening faster now, or we can do more work because you're recovering quicker. So we're trying to figure out in those buckets, and we have a whole host of things that we measure, biomarkers and surveys and everything else that we go through to find out what's there. So after we've done that, now we're just going to track a few of these recovery markers along the way to figure out what's globally happening. So that could mean grip strength. I have some folks who we're going to test grip strength daily. Others, we're going to look at HRV or combinations. We may look at performance metrics like a force plate. So you're going to do a vertical jump every single day, and we're going to see where that's at. We've used the tap test before, which is how many times you can tap your finger as fast as possible. It's a rough indicator of central nervous system.
In a, say, 1 minute interval.
Exactly. And there's just apps you can do on this. Like you tap his finger as fast as you can. And it's going to say, hey, you did 60 taps today and your average is 75.
I like that because it taps into, no pun intended, into upper motor neuron capacity. Because
100%.
a lot of things like grip strength, obviously I have to send the deliberate signal to my hand to grip, but at some point the lower motor neurons are going to be taking over the majority of the work. Like the signal is probably one and done, whereas the tapping is going to be repetitive sending of signals from upper motor neurons.
Yep. So some of the athletes I work with, we track blood every day. We track urine every day. We track ideally a combination of subjective and objective measures. Everything from how did you feel last night to environmental sensors of their bedroom, full PSGs going on, running like actual sleep diagnostics, not an Aura ring, nothing against Aura, but like full analytics. And some of them it's as simple as how'd you feel today and what was your vertical jump? Right. So we're going to put people in a position to succeed. We're going to figure out what's the lever that they need to pull, as well as what's their aptitude, what sport are they in, what can we realistically get away with. And some of them will take machines with them and we'll do blood every day and urine and all kinds of stuff. And some of them it's a lot lower.
For myself, I'm not, as I mentioned before, I'm not a big fan of devices. I'm trying to wear the wristwatch. I tend to go off feel, which is not, it's not the ideal objective way to gauge things. But part of my reasoning for this is my colleague from the psychology department, Dr. Aaliyah Crum, has done some studies where they've deliberately given people false feedback about their sleep. So told people you didn't sleep very well, or they've told people you slept really well. And performance can be driven in the expected direction based on feedback, independent of how well people slept or didn't sleep. Now, that doesn't mean you can take someone that only slept 2 hours or was up every 30 seconds because of apnea and tell them they slept great and they're going to perform great cognitive tasks. But you can take someone who slept very well, tell them that their recovery quotient wasn't very good, and their output is going to be worse. And that's my concern about a lot of devices out there, not to name specific devices, but it's still unclear to the general public what the specific algorithms are to generate these recovery scores, right? And so many of the things that reportedly track sleep aren't tracking sleep. They're tracking heart rate and breathing, which are correlates of sleep depth, but that's different. And again, I'm not knocking those. I think the sleep trackers, if nothing else, have provided a forum whereby people are very conscious of getting good sleep. It's sort of like knowing the total caloric intake of your food. People go, wow, I'm actually eating a lot more than I thought.
It's calibration.
Or less in some cases, but often the case is that it's more. So I think for the typical person, I'm wondering whether or not, like myself, because I'm not a competitive athlete or certainly not a professional athlete, competitive with myself, I suppose, but no one else. Morning pulse rate, I tend to take when on waking. If I wake out of a really stressful dream, I might relax a little bit and then just take my pulse rate, kind of get a range and see if it's spiking for whatever reason. I don't tend to measure grip strength, although I've heard you can just use a classic scale. Old-fashioned scale with the needle, now old-fashioned, or some other more technical device is probably good if there's a low-cost one.
Yeah, they're all low.
And then the carbon dioxide tolerance test. So we haven't really talked about that in specific ways. My understanding of it is it's 4 deep, slow breaths, in through the nose, out through the nose, and then a big inhale as max exhale, and then time duration of exhale through the nose. And then stopping the stopwatch at the point where lungs are empty, not necessarily as long as one could hold their breath. Did I get that right?
Pretty much.
Okay, and I guess we should credit you and Brian McKenzie.
Those guys.
Yeah,
for sure.
And the folks under Brian's umbrella for really establishing this as a really good metric. When and how can I use the carbon dioxide tolerance test to gauge recovery? Upon waking, post training session?
Yeah.
Would that be a good time?
Number one answer is whatever you do be consistent. So do it under like any good science experiment, do it under the exact same conditions as you can. That generally means somewhere in the morning, because that's when you're probably going to have the most control, most stability. going. So yeah, like you would take any HRV or other metric, wake up, get under control, get stabilized, take your metric.
Got it.
Going to be pretty good.
Got it.